let us look at the types of maintenance that we have, okay? So that we'll know the areas that our tests and measurement program will actually fit into. Now, maintenance can be broadly, well, however you look at it. Okay, we know we have different types of maintenance, ranging from breakdown through periodic maintenance, that is preventive maintenance, condition monitoring, predictive maintenance, to reliability-centered maintenance, precision maintenance, and what have you. All of them put together, okay, they always fall into two broad categories, okay, which is what you are seeing on the screen. One is preventive maintenance, and the other is corrective maintenance. So we'll see the various maintenance programs that falls into these two categories, okay. So the name preventive maintenance, maintenance that is deployed to prevent failure. Are we getting it? So any kind of maintenance program that you have in place in your facility to prevent the equipment from failing, the electrical asset from failing, that is a preventive maintenance. Then we have corrective maintenance. That means the equipment has failed, okay? So we want to restore it back into its functional status. That is corrective maintenance, okay? There is a fault condition that you want to correct. So under predictive maintenance, preventive maintenance, like I said earlier, we have the predetermined maintenance, okay, which is the scheduled maintenance. Okay, remember earlier in this section we talked about run to failure or breakdown maintenance. That's a maintenance strategy, okay. But if you allow an equipment to run to failure, there are dangers associated with such kind of maintenance strategy. In that, as the particular equipment fails, it can cause problem either downstream or upstream. Are we getting it? Which means other equipment, okay, in line with that equipment can also be affected. The operations would be affected. And maintenance that you actually do not plan for is usually very more expensive than the one planned for. Okay, so those are some of the drawbacks. But if you look at the economics and see that breakdown maintenance is okay and that it is feasible within your facility and that there won't be much effect on your process, of course you can allow that component or equipment to run to failure. Okay, so the next step of maintenance strategy higher than that or more better than your run to failure strategy is the time-based maintenance or preventive maintenance program. This maintenance program is usually informed by tests carried out by manufacturers and feedbacks from users like us, okay. So these feedbacks makes them to, that is, will give them an idea as to how long a particular component within the system, when subjected to a particular stress level, will fail, okay. So if you are looking at, say for example, you are looking at bearing, or in this case electrical, let's say the insulation of a particular system. So that insulation, when subjected to a particular stress level, from test results, from feedback from users, they've come to realize that within 2 years, as an example, within 2 years, this insulation will deteriorate, okay? So they can suggest or advise that within 2 years, change that particular insulation of this equipment or carry out this test, okay, to ascertain that this equipment is failing already within 1 or 2 years, okay. So that will now inform what we'll now use as the basis for our time-based maintenance or our scheduled maintenance program, okay. or our preventive maintenance program. Okay, but over time we come to realize that there are some components that you want to change. As you are changing the component, you will see that that component still have some useful life in them. Okay, which means that that useful life will now become wasted resources. Economically, it's not too good for your operations. Okay, so what are some strategies that we can use to know when this equipment is failing? That is what informs the condition-based maintenance. Maintenance that is carried out based on the condition of the equipment, not based on time of operations. Are we getting it? The one that is even based on time of operation, there are some equipment that fails or component that fails before the scheduled maintenance time. Okay? And the results are usually catastrophic. But if it is based on the condition, when the condition is deteriorating, you will see it and be able to carry out restorative actions. Okay? There are times it is the time for PM, preventive maintenance program. When you carry out condition-based maintenance tests on them, okay, you will see that the components have useful life. You allow the component of the equipment to run. Are we getting it? So that you'll be able to harness the useful life that is left in the equipment and save your facility a lot of money that would have been spent on the maintenance program that is not required. Okay, so the test results that you get under your condition-based maintenance, you can use it to schedule your maintenance program. Okay, then when you come to the right part, you see corrective maintenance, it has failed. Okay, and once an asset fails, they usually that fire brigade approach. So we want to fix the problem, and in doing that, we can reduce other problems, maintenance-induced problems in the facility, and also we can also incur more costs. Are we getting it in fixing that particular? In most cases, it is usually more than 3-5 times what you would have spent ordinarily if you knew that problem was developing and then take care. There are times too, the cost of even fixing the problem, you see that it may not be up to 10% of what you spend when the equipment fails if you have a good maintenance strategy in place. Okay, so these are the various maintenance strategies that you will see, and in each of them you deploy your maintenance, electrical maintenance and testing. Okay, during your preventive maintenance program, if you have good preventive maintenance program or reliability centered maintenance program that harnesses the advantages of all of these maintenance strategies. So this is the bathtub curve that we were discussing about. So this is this is on the vertical axis. We have the failure rate or the potential, the failure probability. Okay, and then the horizontal axis is the time axis. Usually, when an equipment is installed, it has a very high rate, that is high probability of failure. Are we getting it? And that is as a result of maybe installation error, design error, okay, or manufacturing error at the manufacturing plant, and even bringing the equipment from your manufacturer to site. Okay, transporting that is not properly handling the equipment during transportation. All of this can induce some fault condition that will result to infant mortality or early failure of the equipment. So when the equipment is into service, you'll see that after some time it will bed in, and then the probability of failure will now stabilize over the operational life of the equipment. So any failure that occurs here, it will probably due to maloperations, okay? You operating the equipment wrongly. And then if you look at the curve too, you see the wear out area. This area, you see that the probability of failure rate has increased or will be increasing from this point. Okay, this is usually due to old age. The equipment have served out its terms. Okay, so when you are carrying out your tests, what you will be looking at is trying to catch that particular equipment when it is entering this failure, this way out area. Okay, this is the potential point of when it is entering this failure area. This is the potential point of failure, and this is the point of failure. Okay, so if you are trending, okay, during normal operations, you see your trend somewhat like this around the fixed area, but once problem starts developing, you see the deterioration. Okay, so once you see the curve like this, that is a sign that you should